Okay, the second big idea in section 3.3 is this capital N. I would probably just refer to this as the normal vector, but technically it's known as the principal unit normal vector. It's a unit normal vector because it is of magnitude 1. We normalize something. And it's called the principal because there are two unit normal vectors, and this is the one that is principal. And I will explain what that means. Right. So first, the definition. How do you get this capital N? Right. So the N of t, this is a vector with respect to t, and so the way you get this is, remember what capital T is? That's a unit normal, the unit tangent vector, and then we take the derivative of that. Okay, so that would be t prime, and that is the derivative of the unit tangent vector, and of course the tangent vector itself has, is obtained by differentiating something. And then we normalize it. Okay, so this is, you can call this the normalized Tn. Okay, so this is normalized unit tangent vector. And that's what's called the unit normal vector, or the principal unit normal vector. And by the way, it is different from taking the second derivative and normalizing it. Okay, it is not the same as taking the second derivative and normalizing it. Let me explain what I mean by this. Right? This picture, I think, would be helpful. Unfortunately, I have not seen this in sort of any book. Maybe I should write a book and then have this patented. All right, so you start with a vector valued function, right? Like describing the motion of a spacecraft or something. And then you take the derivative of it. What do you get when you take the derivative of r? You get r prime, right? Yeah, it's the velocity. And then you normalize it, and that is now called the unit tangent vector, right? And now what we are saying is you do the same thing again. Differentiate and normalize. If you differentiate this, it's just called t prime. And then you normalize it, it is called the principal unit normal vector. So procedure-wise, it's pretty simple, right? You start with a vector valued function, you differentiate and normalize. You get capital T. You differentiate and normalize again, and then you get capital N. What can be simpler than that? Well, actually, it could be quite complicated. Let me first give you an example, right? And then we can talk about what it actually means geometrically, right? So let's find the principal unit normal vector for our helix. This is a sort of, always a to-go kind of example here. It's what? Cosine t, sine t, and t, okay? And so at r, and by the way, t can be anything. I don't have to restrict it to from 0 to 2 pi. Okay, so r prime is negative sine t, cosine t, 0, right? What do? You normalize it, okay? So capital T, oh yeah, so you have to know what the norm of this is. And fortunately, sorry, that is not correct, it's 1. All right. Fortunately, we have done this already. It's a square root of sine square plus cosine square plus 1, okay? And this is actually known as square root of 2, all right? So then t, capital T of t, which is the normalized version, that's 1 square root of 2 times negative sine t cosine t 1. Okay, all I'm doing is normalizing that velocity vector, right? And since the velocity vector has that one extra component, it's the velocity vector is not of the length 0. The length is square root of 2. It's nice when this is constant, by the way. I'll give you an example when this is not constant, because then taking the derivative of t could be terribly, terribly messy, okay? I don't know if I gave you really messy calculations on your homework. I try to avoid those, but sometimes you may have to do some messy calculations. All right, so let's take the derivative of this. The derivative is of a constant. You can take the constant out first. So I'm going to keep that constant 1 over square root of 2 outside of this. The derivative of negative sine is negative cosine. The derivative of cosine is negative sine. The derivative of constant 1 is 0, right? Okay, now we normalize this. What is the norm of t prime? Okay, well, it's this times the norm of, the other part, because the constant multiple can still be taken outside, but you can readily see that this second part, the vector part of this is actually just a unit vector because it's just cosine and sine. The signs, signs as in plus and minus, they're irrelevant. Okay, so this is 1 over the square root of 2. Okay, so if you divide this, t prime, and you got to be careful here, t prime divided by its norm, you're basically dividing this thing, okay, you're dividing this thing by the 1 over the square root of 2, which is multiplying by the square root of 2. Basically, that thing cancels. Okay, so all you get is this. And by the way, that's not surprising, right? Because really, when you normalize it, you're trying to find the vector in the direction of the given vector that's normal, that's normalized, which means a unit vector. So you're looking for the unit vector in, what am I saying? The unit vector in the direction of that. Okay, well, you already know what the unit vector is, which is the inside of this. Okay, so we just eliminate that constant that appears at the front, and that is your unit normal vector. And this is the principal unit normal vector. Right? And of course, you can plug in t for any specific value, and you can calculate the unit normal vector at that particular point. All right, so here's the fact, and this is a very important, let's just call this facts, okay? Number 1, recall t is a unit tangent vector. So it is a constant length function, right? So by the theorem that we learned last time, t prime, t prime is perpendicular to t by the theorem that we learned recently. Okay, well, since n is only the normalized version of t prime, n is of course parallel to t prime. Okay, so all this is saying is this, and this is important. Let me write this in red. N has to be, because n has the same direction as t prime, n and t are perpendicular to each other. Okay, so this is one important thing that you need to remember. Okay, and then the second thing is, of course, since n is normalized, the norm of n is 1, right? So what does it tell you? Okay, so it tells you that if you have a motion like this, and if your t happens, of course, t is your tangent, unit tangent vector, right? The length, this is the unit vector in the direction of the motion at that particular point. And of course, it's tangent to the motion. In this example here, this is r of t. Okay, so now look at what what n is. N is the normalized vector in the direction of t prime. Now t prime is going to tell you how t, capital T, is changing. All right, so if you look at capital T here, it's changing from here like this, here like this. It's kind of going toward the left, right? It's like curving or veering toward the left, and it is perpendicular to n. And so n happens to be, so okay, so t is going from this one here, and then this, and then this. So it's kind of going toward the left, and n is showing you how t is changing direction. And so n is saying, hey, you start to go this way. And remember, this is perpendicular, and this is perpendicular, this is perpendicular. That's what n is doing. So n is pointing to the inward direction of how t is changing, okay? So n is the unit vector perpendicular to t, which means, well, it doesn't mean that, but further, because it is the derivative of t normalized, pointing inward, inward to inward. I guess I should just say pointing inward okay, to the center of the circle, right? To the inside of the circle. It's not a circle, but I mean, you can define the circle, which is called a special name. But anyway, so it's pointing inward. Okay, so that's what the n is doing. N is perpendicular to t, and it's showing you which is inside. And by the way, the fact that this is inside, that's what makes this. That's why we call this the principal, right? Because the thing is, if you have t like this, there are two perpendicular directions, this way and this way, and then n is always showing you which is inside. And that's why it is called a principal, or the principal unit normal vector. All right, so that's what the geometric meaning of capital N is. All right, now with that, I want you to, and think about this, all right, and you'll run into a problem, and that's by intention, right? And so before we go into the next section of this video, lesson for section 3.3, I want you to think of RT, which is 2t square, t square, 4t square, right? Try to find t and n, okay? And when you get stuck, come back and we'll talk about it.